Okay, so hi everyone, this is lesson 2 of Python course, and today we'll be talking about functions and conditionals. So first of all, functions will be rather lightweight, it'll take around 15 minutes, and then conditionals will take the remaining 30 minutes or so. The previous lesson, I actually did 45 minutes in total, but yeah, so it might be a bit faster today. Okay, so first of all, what functions in Python is actually quite similar to math. They can take in some inputs, right? A few inputs, perhaps one or two, it's up to you to define, and then they may or may not return an output. So functions are actually subroutines that help you execute a certain task given some parameters. So you can think of it as a factory, right? You can give it some inputs, some settings, and then the factory will do something, and perhaps perhaps the function would just execute some task without returning anything, or perhaps it could return a value and it can store the value in a variable. So first of all, defining a function is simple using the define keyword. So you write def to define the function, and then you use the words, and then after that you write the name of the function you want. So for example, we want to write a function called square this number. Then we have the round brackets, and inside the round brackets, you put in the parameters that you want to pass in. So for example, I want to pass in one parameter with the variable name x, then I put in x like that. And then I write the colon. Then if you want to put in multiple parameters, you can separate them with commas. So for example, x, y, z, or something. But let's just do one parameter, one variable for now. So now inside this function, there'll be a variable named x. So this x would be the value of the parameter passing data, which you'll see. So let's say that's this function just to print x times x. Okay, and if you go ahead and run this code, you're going to see that it currently does nothing, because this line one we define the function. Line 2 is some code inside the function, but we haven't called the function yet. So right now it doesn't print anything. But if we go ahead and write code here, square this number, we call the function by writing the function name like that, and we write round brackets, and inside the round brackets we put in the parameters that we want to pass in. So for example, we want to pass in the parameter 3, so x will be equal to 3, right? And then we print x times x. When we print run, we see 9. So one thing to note is that there's this spacing over here. This spacing over here indicates that whatever code with this spacing is within the function. So for example, this line 2 is inside the function, line 3 will be inside the function, line 4 will be inside the function, but as soon as you don't have the indentation, line 5 will not be inside the function anymore. So this line 5 is code that's not inside the function, whereas line 2, 3, 4 are code that's inside the function, similar to the behavior of for loops. Yeah. We can also call a function multiple times or with different parameters. So for example, we call it again with a parameter 5 instead. So x equals to 5. And let's say we call it one more time with x equals to 25. And we press run. We're going to see that the Python, it executes the code incrementally. So it goes line by line. So when it goes to line 1, it's going to see, okay, when defining a function, line 2 is the code inside the function. Then line 4 is going to be calling the function with parameter x equals to 3. So we're going to print 3 times 3, which is 9. Then square with parameter x equals to 5 is going to print 5 times 5, which is 25. And line 6 is going to print 25 times 25, which is 625. So function names also follow the identical rules to variable names, right? Function names, they cannot have spacing, and they are case sensitive as well. Okay, so let's have another example of defining a function. So for example, we want to define a function to create a list of a certain size, and the size we can decide via the parameter. So we can define a function called make a list, and pass in the parameter size as the variable. So then inside the function we have some code, right? So some code. Then so after that we can call the function with the parameter size. So what would this some code be? So if you want to create a list of size, right? Then we are going to need a for loop. So we first start out with an empty list. We can call this list anything we want. Then we can use a for loop, right? We need to put in size number of items. So we need to run we need to append to the list size number of times. So we write a for loop for I in range size. So now whatever code that's indented with 2 indents, right? Whatever code is line 4 is going to be executed size number of times. So what is going to be executed is going to be my list of append. You write any number in here. Let's just append I. And it will print my list. Okay, so after create the list, after the for loop, after we append to the list I a size number of times, then we're going to print the list. So let's just call the function, make a list with the parameter size equal to 3. We press run, we're going to see that it prints 0, 1, and 2. So why is that so? We inspect how the code works. We're going to see that we're going to pass in the variable size equals to 3. Then my list is going to create a blank list at first. So whatever is in line 2 to 5, right? Line 2 to 5 is part of the function. And yeah, so line 2 to 5 is going to be executed when we call the function make a list. So we call the function make a list with the variable size equals to 3, the parameter size equals to 3. Then line 2 creates a blank list. Line 3 has a for loop, right? And it executes line 4 with the 2 double indentation. It executes line 4 size number of times, 3 times, because size equals to 3. Then we append I, which takes the values 0, 1, and 2 for each iteration. And at the end of it, we print my list. So if we go ahead and let's say we write I times 2 over here, then the list, instead of appending 0, 1, and 2, it's going to append double of that. So it's going to append, if we press run, it's going to append 0, 2, 4. But let's just revert it back, and you can also call make a list with different parameter values. So let's say we call one with 10, one call with 25. You'll see that for each one of those, our function is going to generate lists of different sizes. So you can see that you think of going back to my factory analogy, you think of make a list as a factory that creates lists. Then size is a parameter that is a setting, right? That we can tweak to adjust the behavior of our factory, our function. So this function can perform certain tasks, right? It can, if you write more complicated functions, it could, for example, calculate the Fibonacci numbers, or it could calculate the square root of a number, and so on. So that's what briefly what functions does. So now we know that we can pass in parameters, but functions, they can take in inputs and they can also return outputs. So at the moment, our function does it does the following thing. It creates a list of length size, and after that it doesn't return anything. But can our function have an output as well? The answer is yes, it can. So we define my function, right? So my function is the name of my function, and we pass in the parameter a. Then let's just write return a times 3. So what does this return keyword do? This return keyword essentially outputs, it lets the function output a value. So for example, if I go ahead and run my function 2 right now, and I press enter, you're going to see that there's no output, right? There's no output because there's no print statement. However, if I write print my function 2, then if I press run, you're going to see 6. So why is that so? Because we pass in the parameter a equals to 2, right? A equals to 2 goes into the function, then it returns 2 times 3. So when we have returned 2 times 3, right, this function is now, it now outputs 2 times 3, which is 6. So this function, my function 2, essentially is being replaced by the value 6 because it returns, it's the output of the function. Yeah. So from there, it just becomes print 6, which is why we see print 6, which is why we see 6 as output. So yeah, so we can also change this parameter to another value, right? And you see that output update accordingly. So that's returning a value, right? And besides, so right now it might seem there's no difference between just printing it the function and why can't we just write print a times 3 instead of returning it, right? But the answer to that is that when your function returns a value, the output, right, you can store it in a variable and you can do anything else you want to do with it. So for example, instead of printing my function 20, I can have I can store the output in a variable. So I have x equals to my function 20. So now essentially my function 20, a equals to 20 will be passed into as a parameter, returns 20 times 3, it'll be x equals to 60. Right? So from here, I print x, you can see that I see 60 as well. And from here, I can also do whatever I want with variables, because now my variable x is a container that stores information, right? It stores 60. So now I can do whatever I want with it, just like how we explored with variables in the first lesson. So yeah, then in addition to that, your function can also, you can also take the output of your function and pass it as an input to another function. So for example, I have print my function 10, right? Right now I'm going to get 30. Then I can, if I want, right, I can also take this, the output of this function 30, right, which is 30, the output of this function which is 30, and I can pass it into the input of another function or the same function. So I call my function 10. If you have studied functions in math, you know that this is known as function composition, right? You take the output of a function and you put it into the input of another function. So in this case, I can my function 10. So I press this, run, I'm going to get 90 because the first call, right, is this, my function 10 is going to return 30. And then after that, my function 30 is going to return 900, which is why we see print 900. So the upshot of this is that return is quite a powerful tool because it can return, it's basically an output of a function. So instead of just having a function print some computations, it can also return a value, and from there you can play around with it, store it in a variable and do whatever you want. Okay, so now we can have multiple functions as well, just how we have multiple variables. So let's say we have and the function can call each other. So let's say we have a function called square, which takes in the input a, and it returns a times a, so it returns the square of a number. Then we have another function at 1, which takes in the parameter a, and it returns a plus 1. So your other we've identified a function called weird, right? It takes in parameter a. You can also call the other functions. So what does this mean? So this means that my function weird can actually call my square function or add one function. So let's say I create a variable inside the function weird. I create a variable x equals to square of a. So what this means later you see is that when I call the function weird, right, you go to line 8, and then 8 is going to create a variable x and assign it to the value of whatever, and assign it to the value of whatever the square a returns. So it's going to call square a. It's like subroutines. So I have a it's like I call a function weird, right? And I say, hey, can you do some? I'm calling you. Can you do certain things? Then weird is going to call square. So weird is going to, the function weird is going to call the function square, and square is going to return some value, and then weird is going to process that value in whatever way it wants. So the point is functions are basically subroutines, right? Right? Your entire program is a routine, but functions are subroutines that can return a value, they can perform certain computations, and then they can call one another also. So you can have one function that calls another, you can take the output of one function and pass it into the parameter of another function and so on. So if I just have this, and let's say I return x, so you're gonna see, okay, so we're gonna call the functions and see what they output. Okay, but before that, let me just mention that when you see right now so-called clashing variable names, right? Because we have a here and a here, but do note that the variable in this, the a variable in here is different from the a variable in here. Basically, they're different variables. When you call a temporary variable is created inside the function. So whatever is happening inside these indented blocks, right? It's going to remember you're gonna have access to the value a, but after that, after you exit from the function, the variable a is going to be destroyed. So point is that yeah, the variables, the parameters, right, they are called the same thing, they are the same name, but they don't talk to one another because they exist in different functions. So this is also known as variable scoping, which I will probably elaborate on in lesson 5. Yeah. So, okay, so now we have three functions, right? And the function weird calls the other two functions. So let's go ahead and print some value. So we print square of 3, right? We're going to call the function square with the parameter a equals to 3. So a is going to be replaced by the value 3. Return a times a. So square 3 is going to return 9. And we print, we see 9. Then if we go and print at 1, 10, we're going to see that passing a equals 10 returns 11, we see 11. And then let's see what happens when we call weird2, right? So we call the function weird with the parameter a equals to 2. Then we're going to see the value 5. And why is that so? That is so because when we call weird of 2, right, we pass in a equals to 2, right? Then in the next line, x equals to square of a, which is square of 2, which is returns 4. So x equals to 4. The next line, x equals to add 1 of x, which is add 1 of 4, which is going to give you 5. And at the end of it, we return x, which is return 5, and that's why we print 5. So the point of this lesson, the point of this slide is that your functions can call other functions, and your other functions can also call other functions, and you have a whole chain of calling. And in fact, that's what happens in most programs, because it calls a whole sequence of functions until it reaches the kind of the base one, and then it starts propagating upwards. So yeah, that's pretty much for functions. Yeah. So okay, I hope that wasn't too heavy, because conditionals is going to take up most of the lesson today. So okay, I have a question. Can functions only call on functions in preceding lines, or any function you have written? I think you can only call functions in preceding lines. Let's give it a try. So that's a good question. Very good question. So let's try this. Okay, we try run. Oh, and there wasn't an error. What if we do this? What if we do this? You see, as you see, I'm also, as you're asking the question, I'm also exploring it myself. So the question was, what can functions only call functions in the preceding lines, right? Meaning that if I want to call the square function in the weird function, it must come before, it must come before my definition of square and add 1, or can I call it first and then define it later? And it seems like the answer is you see, if I try to have, if a function weird and I call square before it's defined, then it throws an error saying square is not defined yet. Yeah, so the answer to that is yes, you must define it first. Yeah. So I hope that answers your question. Okay, so now, any other questions? I encourage you guys to really ask questions. Yeah, I think you guys are quite shy. You haven't been asking a lot of questions. So yeah, please ask more questions. Then. Okay, so anyway, let's move on to conditionals, adding logic to your program. So what is conditionals? Conditionals are a way to direct your program flow depending on some conditions. So before we go to conditionals, perhaps it'll be useful to talk about input, because any user input is one of the ways to sort of play with conditionals. So previously we talked about variables, and we know the variables can store information, but previously we just have the variable store whatever information. So for example, animals or cat. But let's say this is quite boring, because whatever we want to implement, we need to type it into the code. Let's say we want to execute the program, and the program can talk to the user. So so we can do something like that, right? So if we print animal, oh, what is the link? I just joined. Sorry, I'm a bit confused. What do you mean by what is the link? The website. Oh, currently, oh, okay, sure. You're asking for the RETL.IT. This is the website. Okay, so here's the website for you to try your own Python interpreter. You have your own Python interpreter, but most of the code I'll be executing it's on screen, so you can just watch the screen. Yeah. So let's say I have animal equals to, and I call the function, right? Remember when we write something like that, it's actually calling a function. It's a function defined by Python itself. We didn't define it, but it's a function defined by Python itself. Yeah, so it's a function defined by Python itself. We press run, we can see that currently it's not outputting anything yet. Why isn't it not outputting? Because actually we're stuck in line 1 execution. So currently it's at line 1 and the program is waiting for us to input something. So you can input whatever you want, right? ASDF 1, 2, 3. Then when we press enter, it's going to set animal equals to whatever we inputted. So now animal equals to this string, right? And we print animal, which is why we see it like that. So perhaps right now it's not very clear what we need to do. So perhaps we want to ask for a prompt. So inside this input function, we can pass in as a parameter. Inside this round brackets, we can pass in as a parameter the prompt that we want to ask the user. So for example, we say, what is your favorite animal? Okay, then after that, perhaps I want to say, I also like animal, exclamation mark. So let's go ahead and run this. So now we see that instead of having just a blank thing waiting for us to input something, they actually printed a prompt, right? And then we can type in whatever we want. So let's say I like cats, right? So I say my favorite animal, I type cat and I press enter. When I press enter, animal is going to store the user's input, which is cat. Then in the next line, so now line 2, animal stores the value cat, right? The string cat. Then it's going to say, I also like animal, I also like cat, exclamation mark. So that's how you take in user input, right? Okay, now let's think of a different example. What if we want to ask a person for his favorite number? Okay, so number equals to what is your favorite number? Now let's go ahead and print the number times let's say 3. Okay, we want to triple his favorite number and print it out. Then if you press run, you're going to see what is your favorite number. Let's say my favorite number is 12. Okay, instead of seeing 12 times 3, which is 26, which is 36, right? We saw 12 times 12, 12, 12. And why is that so? That's because, right, when we take in user input, it's actually taken in as a string. So what does that mean? It means that the user input is going to be number equals to whatever the user input is going to be put inside a string. So in this case, we input 12, even though it's a number, right? Python still thinks of it as a string with quotation marks, which is like a sentence. And when we take this one times 3, it says we have a string times 3, right? Then what it does is it multiplies when we multiply a string by a number, it repeats the string the number of times. So in this case, it's string, string, string. So what happens over here is that when we input 12, right, Python is thinking it as a number as 12 with the quotation marks. And then when 12 with the quotation marks times 3, it gets you 12, 12, 12. So that's not what we want. Instead, we want 12 times 3 without the quotation mark. So we want something like that, which is 36. So how do we do that? So instead of having the number with the quotation marks, we want it without the quotation mark. So to do so, we need to do something called conversion of variable type. So we need to convert the string to integer, right? Currently, number is a string. We need to convert it to an integer. How do we do so? We can set number equals to integer of number. So remember that equal sign is a replacement, right? It's an assignment of a new value. So we're assigning the variable number, we're assigning the variable number a new value of integer of number. So it's going to be like integer of 12, and inside here it's going to be 12, and that's why we convert it into we convert the string into a number. So we go ahead and run this, then we press 12. We're going to see that instead of seeing 12, 12, 12, we're going to see 36 as expected. So the upshot of this is that if you want to take in user input, right, that is a number, then you need to convert it into an integer, because the user input is by default interpreted as a string. So another way to do this is just using int input like that. So we are passing in the output of we're passing in whatever the input, right, the user input, into the int function, which converts the string into an integer. When we press run, we can see that we're going to get 36. is one thing that we can note, if you try to type in something that's not a number, Python is going to throw an error saying that line 1, right, in line 1, there's an invalid literal for something with base 10. Basically, the ASDF cannot be converted into an integer. So that is inputting integers. You can also input decimals, right? If you try to input decimals with the int over here, which converts strings to integers, then you should see an error. Because it says 12.5 cannot be interpreted as an integer, cannot be converted to integer. So you can use float instead, which basically is a decimal. It has a keyword. Yeah, so 12.4, now it works. Okay, so that's inputting numbers. So now we are ready to talk about conditionals. So let's say we take in the user's input, and depending on the user's input, we have to do different behavior. So let's say if the user, one simple example is, for example, with a website, right? If the user inputs the correct password, we want to let him into the page. Whereas if he inputs the wrong password, we want to prevent him from going to the page. So we need to have a way of letting Python redirect the code flow, right? Redirect the code flow depending on whether some conditions are met. So for example, we have animal, because we have taken the user's input, asking him for his favorite animal. Then from there, with web print, I also animal, right? And let's say in between, right, we want to do okay, let's say and then we after that we also say animal is very cool. And let's say in between we have to do some behavior based on the user's input. Okay, so if you go ahead and run this now for now, you type cat, you can see I also like cat, right? And cat is very cool. But let's say inside from a line 4, let's say we want to do we want to have code execute based different code execute depending on the user input. So for example, if the user inputs cat, right, I want to say meow. Otherwise, I want to say not meow. So how do we do that? So we can say we do so using a conditional, something called an if-else statement. So to define an if-else statement, we write if, right, and then we write round brackets, and inside this, we write the conditional that we want to check whether it's true or not. So in this case, we want to check whether animal has the value cat. So to do so, we write animal, the variable name, equals to cat. Okay, and if that is true, if this is true, then we write colon, and we press enter, and you see there's an indentation created by Python, by the editor, right? Then inside here, we're gonna write in whatever code is gonna execute if the condition is true. In this case, print meow. Can have other code also here, as long as it's inside the indented block, as long as it's in the as the indentation, it's going to be executed if the condition holds true. Then, so if you go ahead and run this, you're going to see that if I type in cat, right, it's going to print, I also like cat, meow, cat is very cool. Otherwise, if I type in something other than cat, then it's just going to say, I also like ASDF is very cool. So you can see that depending on our user's input, if the user's input is cat, we have executed and we run line 5, right? Because this condition holds true. And if the user's input is not cat, right? If let's say it's dog, then this condition fails to hold true. Animal equals to cat is false. Then line 5 is not executed. Yeah. So another thing is that so one thing is that you see there's a double equal sign over here. This double equal sign is checking whether the left hand side is equals to the right hand side. In this case, the double equal sign is different from the single equal sign, because the single equal sign we talked about in our first lesson is for assigning a new value on the right hand side, right, to the variable on the left hand side. But in this case, the double equal sign is comparing whether the left hand side is equals to the right hand side, and this entire statement will be either true or false accordingly. So yeah, so okay, then let's say we want to do something if the user's input is not cat, then we can use the else command. So this else command is optional. I mean, you can write it, you can don't write it if you don't want. So we write else, right? So this whatever is in this code line 7 and 8 right now is going to be executed if if the previous conditions will not hold true, did not hold true. So if the animal is not equal to cat, then we print not meow. Then go ahead and run this. So you see that if the user's input, right, is cat, then it prints meow, right? Otherwise, it prints not meow. Okay. So yeah. So that's for if else. Yeah. Okay. Then what if let's say if the user's input is in addition to cat, right? Let's say I want to add an additional condition for dog. So if the user input animal is equals to cat, then I print meow. Otherwise, let's check it if it's a dog. Otherwise, if animal equals dog, print wolf, else print by. Okay, let's go ahead and run this. So in the first input, in the first case, if our user's input is cat, it prints meow. Otherwise, if the user's input is dog, then we're gonna see that it's gonna print wolf because the first condition here fails to hold true, right? Cat, dog, and cat are different. Then it's gonna go into the else statement, which is runs this block of code. So then it's gonna run this block of code and it's gonna look at whether animal is dog, and in this case it is true, so it's gonna print wolf. Otherwise, if I say another thing like turtle, then it's just gonna say bye because the first condition fails to hold true, so it doesn't run this. So it runs the else block. Then if animal is dog doesn't hold true, so it's not going to run this. Instead, it's going to run the else block, which is by. So you can see that using multiple if else statements, you can check in sequence whether it's equals to cat first. Then you can check whether it's equals to dog. Otherwise, I think you can chain it and so on. But this is not the best way to, if you want to put multiple conditions, right, check conditions one by one like that. It's not the best way because you can see that as you go, the indentation gets crazier and crazier. It becomes more and more to the right. So a neater way to do it is just to use the elif command. So instead of writing else if like that, Python allows us to as a simplified version like that. So instead of having else and then if, right, you nested else if statement, you just have elif animal equals to dog. So it's going to check this condition first, right? And it's going to check this condition next. And then it's going to, otherwise, if both of those conditions above fail to hold, it's going to print this. So if I go and run this, you see I type cat, I'm going to get meow. I type dog, I'm going to get wolf. And if I type anything else, I'm going to get bind. So once again, if elif and else statements, you check, you go in sequence, you go from the top one. It's going to check if the first condition holds true. If the first condition holds true, it's going to do whatever is inside the first block, the first indented, whatever is inside the indented block, right? With the indentation like that. Then if the first condition doesn't hold, then it's going to try the next one. It's going to look at this and see if animals will dog. If this holds, if this is true, then it's going to do whatever is inside the indented block, right, for this block. Otherwise, right, it's going to go into the next one. Then finally, when you hit the else one, if all of the above has failed, right, only if all the above has failed, then it's going to run, it's going to execute the else. So is this the first choice? If the first choice is executed, then it's just going to ignore the rest of them. So you can see this important point. I'll illustrate with another example later. If the first condition held true, right? If our user's input was cat, the first condition held true, it's just going to do the first block of code, and it's going to ignore whatever subsequent else if there are. Yeah. So that's for if, elif, and else statements. Yeah. So yeah. So let's go on to the next part. Yeah, so okay, in addition to comparing whether strings are matching, right, you can also compare your conditionals, right, inside the if statements, inside these round brackets, you can also put other conditionals. So for example, we ask for the user's input, which is we ask for the user to input a number. Right, then from here, we want to check whether the user's input is between 1 and 10. So if the number is less than 1, then print number is less than 1. Else, if the number is greater than 10, print the number is less than 10. I mean, sorry, more than 10. Else, finally, print you entered number. Then, yeah, so let's go ahead and run this. So if we put in a number, let's say -2, then we're gonna press enter. We're gonna get, it's gonna fall for the first if statement, right? Because -2 is less than 1, so it's gonna print -2 is less than 1. Otherwise, if let's say we put in something 11, right, then the first statement is not gonna hold true, so it's gonna try the second statement. The second statement holds true, so it's gonna print 11 is more than 10, and it's gonna ignore whatever comes after that, right? But if both of them fail, let's say it's 5, and 5, the first condition, 5 is not less than 1, so it's not gonna run this one. It's gonna go to the next one. 5 is not greater than 10, so it's going to not run this one. It's gonna go to the next one. Okay, we hit the else already. Everything above has failed, so we're gonna print you entered 5. So yeah, so point of this slide is that besides checking whether variables are equals to a certain value, you can also check if they're numbers, right? You can also check with equality and inequality. So okay, this one, let's say instead of writing all this, right, we want to check whether a number is between 1 and 10 directly. So we can write if number is greater than or equal to 1. Right, then if this holds true, you can write if number is less than or equal to 10, then print 0. Right? So we run this, then if our number is between 1 and 10, let's say if our number is between 1 and 10, then it's going to, the first if statement is going to be true. 5 is greater than or equal to 1, right? Then it's going to run the code inside. The line 3 code is going to hold true also, this statement, because 5 is less than or equal to 10. So it's going to print you good. But if you see that if one of them fails, let's say we put 11, is the first one is going to hold true, right? So it's going to execute this code, but then this code, 11 is not less than or equal to 10, so it doesn't run this. It doesn't run this part. It just exits. It just goes, and as soon as there's no else statement, it doesn't print anything. But is there a better way? So you see that if you want to check multiple conditions together, right? If you want to make sure multiple conditions all hold true, then we can do nested if statements just like that. So this is called nested if statements, where you have the double indentation. But is there a better way to do this? The answer is yes. So instead of writing nested if statements, you can use the AND command. So you say if this first condition holds true, right, and the second condition holds true, then we do whatever's inside. We print this, we run this code, you see with type 5, it's going to run, you good. So this is using the AND command, you can check for multiple conditions to hold true. Check for multiple conditions to hold true before you enter the loop. Before you enter the block of code, you run the block of code. So there's also more conditionals. You can put or conditionals. So if number, so you can this is a list of them. So you can check for equality or inequalities like that, right? Or you can check if two numbers are not equal by using exclamation mark. You can also use this is the AND command. So true and true gives you true. It's called a truth table. It's called a truth table, right? True and false gives you false, right? False and true gives you false. False and false gives you false. Then there's also an OR command. There's also an OR logic operand, right? And then it's gonna have, if either A or B is true, it's gonna give you true. So true or false is gonna give you true. False or true is gonna give you true. False or false is gonna give you false. There's also lastly a not, right? Not of true is false. Not of false is true. So now we go on to our first exercise. I invite you to try this for around, stare at it for around 1 minute. See if you can figure out what's gonna be the output. If you figure it out, please type in the chat so I know that you got it. Okay, so I hope that you guys have looked through it. So let's go ahead and see what the output is going to be. The output is actually going to be B and C. So why is that so? So let me just use my pen over here to start annotating the screen. Okay, so you see that we have two variables, A and B. So we define A equals to 2, B equals to 3. So if A is less than, sorry, if A times B is greater than 5, is it true? 6 times 5, sorry. Damn it, I can't, okay, not 6 times 5, sorry. If 2 times 3, 2 times 3 is equal to 6, 6 is greater than 5 is true. So this if statement is true, it's going to execute this block of code and it's going to ignore this block of code. Okay, so in this if statement, it's going to take a look at if 2 is less than 2, is that true? No. So this is not true. So this block of code is not executed. So it's going to take a look at the next condition. Is 3 greater than or equal to 3? It is true. So we're going to print B. So that's why we see B as the first output. Then it's going to go to the next line. If A minus B is less than 0, A minus B, 2 minus 3 is in fact less than equals to 0. Is in fact less than 0. So it's going to print C, which is why we see this. So that's just a simple exercise to see what is to check your understanding of if-else statements. Okay, so now the next thing I want to talk about is FizzBuzz. So actually this is a famous, you see that so far we've just we've just 2 lessons we can do quite a lot of things already. And in fact, this FizzBuzz is a coding question, right? That that you should already have the knowledge to solve. So in coding interviews, there's a coding interview question called FizzBuzz, which is basically print the integers 1 to n, right? You can do so using a for loop. However, there's an exception that if the if the number is divisible by 3, print fizz. If the number is divisible by 5, print buzz. Otherwise, if it's divisible by 15, print FizzBuzz. So you take a look, this is the output that we're supposed to generate. 1, 2, right? Fizz, 4, buzz. 6 is divisible by 3, fizz. 7, 8, blah, blah, so on. And we see 14, FizzBuzz, 16. So 15 is divisible by both 3 and 5, so it's going to print FizzBuzz. So can we write some code to do this? And let's give it a try. So if we try the following code, right? We try the first line we have a for loop, right? That goes from 1 to n. Then in the for loop, we have a few if-else conditionals. So if let's try the following code, right? It's actually a mistake. There's actually a mistake somewhere. But if we first try divisibility by 3, right? If 3 divides the number, then we print fizz. Otherwise, if 5 divides the number, we print buzz. Otherwise, if 3 and 5 divides the number, print FizzBuzz. Lastly, we print the number itself if none of those hold true. So you see that if we run the following code, it looks correct, right? Kind of following the description of the problem, it kind of looks correct. However, you see that there's a problem that when we hit I equals to 15, we have fizz instead of FizzBuzz. So why is that so? That's because when we hit I equals to 15, we are currently at so I equals to 15, right? Then we go to this, and this holds true. So because 3 divides 15, this holds true, and it executes this code, right? And it ignores everything else. Everything else that is ignored. So it prints fizz, which is why here we see fizz. And that's incorrect because we see that we have glossed over, we have missed this code, which we're supposed to print FizzBuzz, and instead we just printed fizz only. So the correct code is instead to put the first conditional FizzBuzz, right? The divisible by 15 condition first, because if I equals to 15, then this holds true, and that's why we see FizzBuzz. Whereas if I is equals to, let's say, 3, right, then this condition is not going to hold true, right? If I equals to 3, then this condition is not going to hold true. So it's good. This is going to be ignored, and it's going to continue printing the correct values for those that are divisible by 3. So the punchline here is that the ordering of the if-else statements is important if you want to get the desired behavior. It's not just a matter of putting the conditions in whatever order you want. Like you need to make sure that if you have overlapping conditions, right, like I equals I divided by 3 and I is equal to 5, along with these, then you put those that are stricter on top first, so that they will be checked first. So now I'm going to go through example of how to use for loops and if else statements to compute the square root of something. So this example is going to be slightly it could be slightly daunting at first, but don't worry if you don't get this example. It's also okay. I just want to give you a bit of exposure to see how with just for loops and if statements, right, we can already compute the square root of a number to show the power of Python. So the code we're going to use is this. So how do you compute the square root? We have the following code. So we first take in the user's input, right? And we convert it to an integer. So input, enter a number to be square rooted. Then we create a variable called x and set it to 0 first. You see what this variable is for later. So then we try a bunch of variables. We try a bunch of attempts for the square root, right? Using a for loop. So it's slowly incremented. So for n range 40, right? 40 is just an arbitrary limit I set. So because the number we input is not going to exceed 1000. So if I times I is less than or equal to y, x equals to I. And then at the end of it, print the square root is the square root of y is x. So we go ahead and try run this. You see, we input, let's say 16, we're going to get 4. And we input 256, we're going to get 16. So why does this work? Right, this works because if we put a bunch of print statements, we are essentially trying numbers, right? We're trying numbers and squaring them to see if they are within the lower bound. And if they're within the lower bound, we set x equals to that value until they exceed the number, right? Then we no longer update x. So if we go ahead and put a bunch of print statements, we have print time I equals to I. Then if it's less than or equals to, then this condition holds true. So we write I times I equals to I times I less than or equals to 1. And otherwise, right, we just put some print saying that I times I is greater than y, ignoring this case. So if you go ahead and run this, we type in 256, we're gonna see that okay, it's trying I equals to 0. So we type 256, it's gonna try I equals to 0 first, right? So it's gonna try I equals to 0. 0 is less than 256, so it's gonna update x to equals to 0. Right? Then in the next iteration, we're gonna try 1, right? So 1 times 1 is less than 256, so it's gonna execute x equals to 1. Then this continues until around here. You see I equals to 15. 225 is still less than 256, so it's gonna execute x equals to 15. Then in the next line, I equals to 16 still holds true. 256 is still less than or equal to 256, so it's gonna set x equals to 16. Then, however, when we reach I equals to 17, you're gonna see that 17 times 17 is not less than or equals to 256. So this conditional fails to hold when I equals to 17, right? And instead, it prints this. So that's what you see. 17 times 17, right? 289 is greater than 256, ignoring the it doesn't run x equals to 17. So this doesn't run x equals to 17, which means that x is currently still stuck at the value 16. And this continues until the for loop finishes. So you see that in the end, x has the value 16 because when I is equals to 16, right? I equals to 16 is the last time, in this for loop, right, that this condition held true. So to repeat, right, we're trying different values of I, slowly incrementing them. We're trying I equals to 0, I equals to 1, all the way to I equals to 39. And for each one of those, if I squared is less than y, then we set x equals to I. And the I equals to 16 is the last time in this for loop, right, that this condition holds true. So we set x equals to 16, and then after that, we do not touch x anymore. Because from then on, 17 times 17 onwards, right, 18 times 18 and so on, it doesn't satisfy this condition, so x is not updated. So this is just and then at the end of it, we just print x. So this is just a rough indication of, this is just a rough guide of how to, how we can string together certain, how we can start to write our first programs to do certain more non-trivial tasks. So yeah, this is just an example of a Python program to compute the square root of a number. Okay, so actually there's also something called the math library. So someone out there has written a better square root function that probably runs faster and is also probably using a more advanced, a more efficient algorithm. So someone out there has written a better function square root, and we can actually, if we write from math import square root, right, we can just call the square root function. We can just call the square root function to get the square root of a number. And this is kind of cheating with the math library. So this math thing is called a library, and it's basically a Python module or library that somebody else out there, some other programmer has written, and now you can use it for free. So you can just import the library and use his code in your own program. So basically, this is the way to share code with others. You write code, right, and then you can upload it to a website called, there's multiple websites that allow you to host it. You can upload your code, and then other people can download your code and they can import your code into their own code and use it. So there's a whole economy of code sharing, and one such website is GitHub, where people can upload their code for anyone to see. And this whole idea of sharing code is called open source, where you open up your source code to the entire world so that they can use it for their benefit. And I'm a big fan of it. I think code sharing is very nice, right? It's a very nice thing that you put in hard work into your code, and then other people can enjoy it. And you can write very good code, right? And people can benefit off your code. So it's like, you don't even need to be there to help them with it. You can just publish it and they can download it and use it themselves. You don't even need to be there to help them write it anymore. So that is open source. And in fact, there are people who write entire libraries. There are people who write entire operating systems. So there's something called Linux, right? You search something called Linux. This is an operating system, right? Like your Mac OS or Windows. Just that the entire operating system, the entire PC's software is open source. Right? It's written in a different language, but yeah, but still the code is still open for everyone to see, and everyone can just contribute, right? And when you contribute to the code, you're helping everyone in the world. And in fact, Linux is the operating system that runs on a lot of devices in the world, right? On your smartphones, use use Linux as a code base, right? Those Android phones, airplanes probably use fridge, your smart fridge, right? Your smart devices, your routers probably use Linux. And many servers like Facebook, Google, they also probably use Linux. Or yeah, at least some of them. So point is, open sourcing code is very good, and I think it's wonderful. So maybe one day you can write code that other people can enjoy using, and it can be run on millions of devices around the world. Yeah. So anyway, that's almost the end. These are some topics that you can further read up on yourself if you want. These are some exercises. You can see them in the third in my third video's rehearsal. Yeah, and so you can try these exercises. And in fact, with this knowledge, right, you can almost code anything you want to think of. So for example, you can already code a simple text-based role playing game. So for example, I ask for, let's say I want to code a game. So I say input your name, right? And then I can have age because input your age. Then I want to convert the age to an integer, right? Then from here I can, let's say, print. So let's say I can print hi, right? And then from here I can say hi, let's say hi to the name. Then if the age is, in fact I can use conditionals to direct the flow of the program. If age is greater than or equal to 18, print welcome to my game. Otherwise, right, print sorry, this game is M18, you're underage, something like that. So you can see that if I type TBH, right, then I type 18, okay, let's say I type 19, right, then it's going to say welcome to my game. But otherwise, if I put my name, okay, I think I lost connection. Okay, if I put my name like that and I run, let's say 17, then it's going to say, sorry, this game is M18, you're underage. So you can see that with this, you can string together multiple if else statements to really start coding your own text-based like role player game. So you can say like you can create variables. You can say like money, right, equals to, let's say you start off with a money of $100. Then let's say your sword price equals to 10, right? And your sword power, you can create variable to store this information, right? And then you can have monsters or something like that, monster health or something. So you can really get creative with all these all these um all these if else statements, and you taking in the user's input. You can use for loop, and in fact in the next example, yeah, that's cool, thanks. Yeah, in fact in the next example we're going to see a very good application where we can actually use dictionaries, right, and to really write a small banking app. So our the console where it sort of simulates a bank where people can withdraw and deposit money and can kind of keep track of how much each person owns. So with just these two lessons and this knowledge, right, you can already go out there and be creative. So yeah, the console is your oyster or whatever. I'll be happy to see you guys try out different programs. So anyway, if not, right, that's the end of the game. Don't be limited. Yeah, don't be limited by yeah, your creativity is the limit. So yeah, if not, that's the end of the lesson. I hope you guys have enjoyed and learned something. If not, yeah, see you next week. Bye-bye. Thank you. Have a nice day. Thank you.